Welcome to the 13th lecture. In previous lecture we have discussed about the evaporation losses, right? We have discussed about the water losses in a canal, and there are two major losses, evaporation and seepage. In previous lecture we have covered the evaporation, why and how evaporation losses occur in a canal and the factors affecting the evaporation losses. And then in today's video we are going to cover our second part, seepage losses. Okay, so it's 13 lecture, seepage and factors affecting seepage. As we have discussed in previous lecture that seepage can be occur in two forms, either percolation or either absorption. Got it? So before discussing about the factors affecting seepage, we will first try to understand the difference between percolation and absorption. What is percolation and what is absorption? So I have drawn two figures to make things clear. As you can see that there are two images, right? This is a cross section of canal and this is cross section of second canal. In the first canal it is showing the percolation process, in the second canal it is showing the absorption. So when it comes to percolation, the basic definition is that when the distance between water table, this is water table level, right? When the distance between your water table and your bottom of your canal is less, then after seepage percolation will occur, because the seeped water, the water which will seep from the canal through the soil, will directly go into the water and submerged into the water table, and it will increase the level of the water table. Got it? So in simple words, you can say that when water seeps from any canal and it submerges into the water table, and if the distance between the canal and water table is very less, so that it seeps and submerge that water into the water table, then that process is known as percolation. But in the second case, when the distance between your water canal and water table is higher, much higher as compared to the first case, in that case the seeped water, when water seeps from the canal, it will not go into the water table. Okay, the water will absorb in some area around the canal. So this condition or this process is known as absorption. Got it? So two things can happen whenever the water seeps from a canal. Whenever water seeps from a canal, either from sides or bed, the first thing that can happen is absorption, and second is percolation. Got it? So this distance between from the top to the water table is known as head in case of percolation, but in case of absorption, the head is not going to be from top to the water table, it is going to be from top to the bottom level of the saturation zone. So in case of absorption, this area is the saturation zone, while in case of percolation, the saturation zone is still the water table. Got it? That's the major difference. In case of absorption, there is a gap between the bottom of the saturation zone to the water table. So that's the basic difference between percolation and absorption. Now let's try to write down some important points related to percolation and absorption. So one thing to note here is that you can notice that the percolation, the head of percolation is less. You can note here that the head of percolation is less as compared to the head of saturation zone. So you can write it, the H1 is representing head of percolation, right? Will be always less than the head of absorption. We represent absorption head with H2 and at H1 is the percolation head. Got it? So this is the basic difference. Let's try to write down some important points related to both terms, percolation and absorption. The first term is percolation losses, right? So for percolation losses, we can say that the water seeps from canal directly. The water that seeps, the water that seeps from canal directly meets groundwater table, right? We have discussed it. Hence, increasing the ground reservoir, right? At the end, it will increase the level of the or capacity of the ground reservoir, and generally it occurs when the distance between ground level and water is less. Got it? We already discussed this point, but we are making notes so that in future, if you want to study it or revise it, things will become easier for you guys. So the next important point is that the flow lines. These are the flow lines. Let me show you the flow lines. These are what? These are flow lines. Okay. So next point is related to flow lines. The flow lines are observed in between bottom of canal and groundwater, right? The flow lines are absorbed between bottom of canal and the groundwater table, and the soil in this zone is completely saturated. And the next important point is H1. We have represented the head with H1, right? H1 or head is defined as head causing flow between free surface of water and top of what? Top of water table. Got it? So H1 is head causing flow between free surface of water. This is free surface of water, right? Free surface of water to the top of the water table in case of percolation. You can define head as this. And last and the most important point is that these losses mean percolation losses, right? These losses depends on permissibility of the soil. This is the most important point you need to remember, that it depends upon the permissibility of the soil. Got it? In case of percolation, it depends upon the permissibility of the soil. This is the point you need to remember: permissibility. Got it? All these three important points are important, but this point is most important among all. Percolation losses depends upon the permissibility of the soil. Okay, so let's move to the next water loss in seepage. That is absorption losses. Okay, let's write down the important points for absorption losses. When water seeps from canal and do not meet with ground water table, right? In case of percolation, when water seeps from canal, it meets with the ground table, right? But in case of absorption, when water seeps from the canal and do not meet with the ground table, but remains absorbed to the voids of soil. It stays absorbed into the voids of the soil up to a certain depth. Okay, in this figure, it doesn't reaches to the water table. It just absorbs to the voids of the soil up to a certain depth from the canal bottom. From the canal bottom is known as absorption losses. So up to a certain depth from canal depth, from canal bottom is known as what? Is known as absorption. Absorption losses or absorption. Got it? And what is the second important point? Generally it occurs when distance between ground level and water table is large or higher. Got it? In the above case, it was generally it occurs when the distance between the ground level and the water table is less, right? So in absorption case, the distance between ground level and water table is larger or higher. Next point is that no flow lines are observed in these losses. These means absorption losses. Got it? Hence, zone between ground level and bottom of absorption is completely saturated and known as saturation zone. But the distance between bottom of saturation zone and water table is either dry or partially saturated. Got it? We are discussing about absorption, right? In absorption, from this to the bottom of the this zone, this area has been saturated. That's why it is called saturation zone. But the remaining area from the bottom of the saturation zone to the top of the water table, this area may be either dry or it may be partially saturated. Got it? So there are two zones in absorption phase. The above one is saturated zone, and after that remaining part is either partially saturated or dry zone. But in case of percolation, the whole area in between the bottom of the canal to the water table is fully saturated. So this is another difference. The next point is that you can say it not partially saturated, you can say it partially, or either you can say it capillary saturated. Right. Next point is definition of the head. How you can define head in this case, in case of absorption. Head causing flow, which we represent with H2 in case of absorption. Head causing flow H2 is defined as the distance or length between what? Between free surface and free surface of water, in canal and bottom of what? Bottom of saturated zone. Got it? And the last point is that the absorption rate generally depends upon, in case of percolation, it depends upon the permissibility of soil, right? But in case of absorption, the rate generally depends upon water holding capacity of soil, and we call that porosity of soil, right? Porosity of soil. So in this case, it depends upon, in case of absorption, it depends upon the porosity of soil, right? This is the point you need to remember. And now let's move into the factors. What are the factors on which the seepage depends? Factors affecting seepage. Let's just write down the names of the factors affecting seepage. First factor affecting the seepage is permeability of soil, right? And the second factor is silt concentration. Let's give it a gap so that we may be able to explain it later on. Second factor is silt concentration in the soil. Third factor is wetted perimeter and cross-sectional area of the canal. Okay. And the other factor, number 4, it depends upon velocity of water. Velocity of water flowing in the canal. Got it? So these are the factors, and the fifth factor is type of seepage. What type of seepage is there? So let's see permeability of soil, how it affects the rate of the seepage. Permeability of soil. Permeability of soil is directly proportional to the seepage losses. If the soil permeability is higher, obviously seepage will increase. Got it? In case of silt concentration, if it increases, this will also increase. In case of silt concentration, if silt concentration is higher, then the seepage losses will decrease. So they have a inverse relation. Seepage losses will decrease in this case. Got it? Because you know silt, what does silt means? Let's say we have some in soil we have few big particles, right? Like this. In between these particles, if silt comes in between the gaps of these big particles, what is going to happen? This will resist, right? Resist the seepage process or flow of water. Due to that, the silt concentration, higher silt concentration will affect the seepage losses, and obviously it will decrease the seepage losses. If there are higher concentration of silt in any soil, then it will reduce the seepage losses. Got it? And the next factor is weighted parameter and cross-sectional area. Obviously, it's very simple that if the weighted parameter of any canal is higher, then there are chances of more seepage. Similarly for the cross-sectional area too. So either weighted parameter or cross-sectional area, if it increases, then your seepage will also increase. They are directly proportional to each other. Next factor is velocity of water. What do you think? What is going to happen if velocity is high in a canal? Seepage will, if velocity is high, then seepage is less. Got it? If velocity is slow, then seepage will increase. What's the reason? Let's take an example. Let's say I have a canal, or let's say water is flowing on a surface which is not straight, right? If I flow the water on this surface with higher velocity, first case, what is going to happen? The water will move fast, right? And it will not stay in this area, and it will move forward because its velocity is fast, right? But in case of slow velocity, if the velocity is slow, then obviously water will stay here for longer time, right? So if it stays longer time, that means that there are chances of seepage. Seepage chances will increase in case of slow flowing of water. Got it? So that's the reason we are saying that if the velocity is high, then seepage will become less. If velocity is slow, then seepage will increase. And the last factor is type of seepage. What kind of seepage is occurring? As we have discussed earlier in this lecture about the types of seepages, which was percolation and absorption, right? So it depends upon percolation and absorption. Either it is percolation or absorption. In case of percolation, the seepage will be higher. In case of absorption, it is going to be less. So your seepage also depends on the type of seepage. What kind of seepage is occurring? Either it is percolation or absorption. So that's it. We are done with the types of water losses in a irrigation canal, and we have also discussed the factors affecting those losses, evaporation and seepage. Got it? So soon we are starting our designing phase. In first phase, we will start with the Kennedy's theory for canal design. So in next lecture, we will introduce this theory. So till then, goodbye. See you guys in next video.